Hello everybody, welcome to session 2 of chapter 4. The objective of today's class is to define and differentiate speed and velocity, to define scalar and vector quantity, to define acceleration and discuss its application, and to prove equations of motion. Speed and velocity. So whenever you are supposed to move from this point to this point, then here we have suppose two different paths. You can go straightly from this point to this point, or you can also use this curve path to reach from initial point to final point. So this straight path is called displacement, and this curve path is called distance. All right. So when a body move from this curve path, then the motion that they have is called speed. And if the body moves in a straight path, then the motion of that body is called velocity. That is why the speed definition, you can say the rate of change of distance. Whenever it travels, then it will change the distance. Okay. So the rate of change of distance per unit time, because whenever it travels the distance, it takes some time to reach from one point to another. That is why the rate of change of distance per unit time is known as speed. And formula of speed is distance d per time t. And SI unit is, the SI unit of distance is meter, and SI unit of time is second. That's why SI unit is meter per second. And CGS unit is distance is centimeter and time is second. That's why CGS unit is centimeter per second. And since speed is produced when the body is moving in this curve path, so whenever body moves through this curve path, it has magnitude. Okay, it will travel with certain value, but the direction is changing in each and every point. Means it has no fixed direction. Only there it has value, magnitude. So since when the body is traveling by speed, it has only magnitude but no direction. That's why it is called scalar quantity. Whereas if you come to velocity, then if the body travels in a straight path, means displacement, then that time velocity is produced. So that's how you can say the definition. The rate of change of displacement means when the body moves through this path, then it is changing the displacement, and it will take certain time to cover this displacement, and that is known as velocity. That is why the rate of change of displacement per unit time is known as velocity. And the formula of velocity is displacement, symbol is capital S, by time. And SI unit is same because it is displacement, SI unit also meter, and time also second. And CGS unit is centimeter per second. And it is vector quantity because velocity is produced when it is traveling in displacement. So you can see here it has a fixed direction plus magnitude, because whenever it moves here, it has got certain motion. So quantity it has got, so it has magnitude as well as direction. That is why it is called vector quantity. So just now we discussed about scalar and vector quantity. So vector quantity means having both direction as well as magnitude, and scalar means the one having the value, magnitude, but no direction. That is called scalar quantity. So that's why definition of scalar quantity is the physical quantity having only magnitude. You can see here it has only magnitude but no direction, no fixed direction. It's known as scalar quantity. Example, distance. So this is distance. See, it has no direction, only magnitude. Speed, because speed is produced when it is body is moving in this curve path. So speed is also scalar quantity. Another example, mass, because mass means we discussed already. It is quantity content. So your quantity does not have, your content does not have any direction. Only it has magnitude. So it is also scalar quantity. And similarly, pressure also has only magnitude. So it is also scalar quantity. Whereas vector quantity, you can see this displacement is a vector quantity because it has fixed direction plus magnitude. That's why the physical quantity having both magnitude and direction is known as vector quantity. An example, displacement. This displacement is vector quantity, and velocity also is vector quantity because velocity is produced when the body moves through the straight path. And weight also has both magnitude and direction because which is caused due to gravity, and the gravity, and it has only the direction always towards the center of the earth. That's why these all the quantities are vector quantity. Average velocity. So here the word average, whenever you have to find the average, then you have to find the mean value of it. So here we have two types of velocities. Initial means beginning velocity, and final means the velocity at the end. So the mean value of these two velocities is known as average velocity. That is why average velocity equal to, since we have two velocities, so how we have to find the velocities, add them first. So u plus b divide. So since we have added two quantities, so divide by 2. So in this way we can find the formula of average velocity. In real life, uh, the body never travels in same velocity. It keeps on changing. Like sometime you may travel with more velocity, your velocity is increasing, and sometime what happens, if you see some hurdle in front, then slowly you apply brakes and your velocity will decrease. So either going speed or you are slowing down your speed. In both cases, what happens is your velocity changing. And the velocity does not change instantly. It will take certain time to change the velocity. So that change of velocity per unit time is known as acceleration. So generally, acceleration means we imagine that in this case, here change means velocity increasing. So increasing velocity is also change of velocity. So the definition of acceleration is the rate of change of velocity per unit time is known as acceleration. And acceleration formula is your change of velocity, and as we said before, there are two types of velocity, final and initial velocity. So all the time final velocity, because here acceleration means we always talk about, think of increasing velocity. So when the velocity is increasing, then velocity, final velocity is always more than the initial. That's why to find the change of velocity, you subtract final velocity with initial velocity, and per unit time, so per means by time. And SI unit of acceleration is meter per square second. And since it has both magnitude and direction, it is vector quantity. And it doesn't mean that all the time velocity will increase. As I said before, if you see some hurdles your in front of you, the driver will apply brakes. So in that case, velocity decreases. Even velocity decreases, the change of velocity has taken place. And that time also acceleration occurs, but that is negative acceleration. And the negative acceleration is called retardation or deceleration, and that's the symbol is minus a. And the formula to calculate acceleration or retardation is same, a equal to b minus u by t. And here we have some sample of numericals. But before going to numericals, these two case that you have to always keep in your mind. If you see such language, if a body starts moving, what does it mean? A body starts moving means before it was in rest. So if you see such language in a numerical, or if a body starts moving, then in that case, initial velocity is always zero. Why? Because it starts moving means at the very beginning it was at rest. So initial velocity is zero. Same way, the body was moving, but because of certain circumstances, the body has to stop. In that case, it will not say that final velocity is zero, but you have to understand final velocity is zero because finally it has already come to rest. So in that case, final velocity is zero. So these two situations, please remember all the time. Now let's go to question. A body starts moving from rest. See here, starts moving from rest means at the very beginning it was at rest. So here I give you already the condition. So initial velocity 0. That's why here also we have already written initial velocity 0. And gains a velocity of 10 meter per second in 2 seconds. But it was at rest, but in 2 seconds that body gain velocity of 10 meter per second. So after 2 seconds means this is final velocity. So we wrote final velocity equal to 10 meter per second, and time taken was 2 seconds. So time t is 2. So here velocity is increasing. It was at 0 at the beginning, but later its velocity is 10. So velocity increasing. The question is asking what is the acceleration. So acceleration is equal to what? So formula of acceleration is a equal to b minus u by t. or a equal to v value is 10, u value is 0, by and time is 2. So 10 minus 0 means 10 by 2, and 10 by 2 means it is 5. So answer is required acceleration is 5 meter per square second. Now let's go to another sample. A bus is moving with velocity of 5 meter per second, means it is moving, means it is initial velocity. So we wrote initial velocity. But what the driver did is, driver brings the bus to rest in 2 seconds. Within 2 seconds, the bus came in rest. So time is 2 seconds, and since it has come to rest finally, so final velocity v equal to 0. And here velocity decreasing. You can see beginning velocity was 5, but later it came to rest. Means here the velocity has decreased. So in such case, what takes place? Retardation or deceleration. So that is the question asking. Now retardation means minus a. Symbol is minus a. Acceleration symbol is a. Retardation symbol is minus a. And formula is same to calculate. So a equal to b minus a by t. A equal to b is 0, u is 5, and time t is 2. So a equal to 0 minus 5 means minus 5 by 2, or a equal to minus 5 by 2 means minus 2.5. So here you got the value of a, but we are supposed to find the value of minus a. That is why what we do, we transfer this minus from here to here. So when you transfer from here to here, then it turns into minus a equal to, since minus has already transferred to the left hand side, so there will be no sign, so it is 2.5. That means retardation is 2.5 meter per square second. Now we have three equations of motions, v equal to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2as. So these three equations of motion, now we are going to prove it, and in your examinations, these last two equations normally asked to prove, because first equation of motion is very simple to prove, so normally this is not asked. Okay, so second and third equations of motions are asked. So if you are asked in exam, write equations of motion, then you can simply write these three equations. What are they? V equal to u plus at, s equal to ut plus half at square, v square equal to u square plus 2as. And these formula are very very important, because based on this formula there will be many numerical problems that you are supposed to solve it. Okay, now we are going to prove it. Now I'm going to prove equations of motions. So the first formula of equation of motion is v equal to u plus at. So here v is final velocity, u is initial velocity, a is acceleration, and t is time taken. Suppose this is a straight line and a body starts to move with initial velocity u and reaches the end of this path with final velocity v, and it took time t, during which acceleration a is produced. according to definition of according to according to according to definition of according to definition of acceleration, we know that acceleration is change of velocity, change of velocity by time. Or acceleration A equal to, when body moves from point initial point to final point, then the velocity has changed from u to v. So the change in velocity is v minus u, and time is t. Now you cross multiply. So when t goes this side, then t will multiply with a, so it becomes at equal to, and here b minus u, so it will be same b minus u. Or if we change the side, then b minus u equal to ut. So finally, b equal to, when u goes this side, it will be plus u, so plus u, and there is no sign means plus, and ut. So in this way, formula b equal to u plus at is proved. Now let's go to another formula. S equal to u t plus half at square. Suppose there is a path and a body is asked to move from here with initial velocity u, and within time t it produces acceleration a and cover the distance s. Now average velocity a b. So average velocity, average means mean velocity, so you can add the mean velocity. So u plus b, there are two velocities, so we add them, and since there are two terms added, so divide by 2. This is expression 1. Again, average velocity is equal to, average velocity means it's a velocity in a simple language, and velocity means distance per unit time. So distance means distance per unit time. So this is expression 2. Now from 1 and 2. So you see 1 and 2, so average velocity is equal to u plus b by 2, and average velocity equal to s by t. That means in place of this average velocity, we can put this value. So when I put this value over here, so how it looks, s by t equal to u plus b by 2. Now, or now see, we have to prove s equal to ut plus half it is. That means this side only s is needed. So that's why let's keep only s here and let's send the other side. So when it goes other side, it will multiply. So it turns into u plus b into t by 2. Now, or s equal to u plus. Now here you can say v, but when you go to question, there is nowhere v. That means this v is not necessary for us. So as we proved before, b means equal to u plus at. That's why in place of v, you will be writing u plus at. Now bracket close by t by 2, or s equal to now within bracket u plus u means 2u plus at and t means, sorry, at and at bracket by t divided by 2. Or s equal to, now multiply by this t inside the bracket, so it becomes now 2 ut plus, when at and t multiply it becomes at square by 2. Now break this expression, so s equal to, when you break this expression then it turns into 2 ut, this 2 will be also divided, so by 2, and here is plus sign, so plus, and a t square, so it will, this 2 will go this side also, so by 2, a t square by 2. So here 2 and 2 we can cancel, so finally s equal to ut plus, here by 2 means 1 by 2 and at square. So in this way this formula also proved. So this is proved. Now let's prove last equation. The last equation is v square equal to u square plus 2a plus. Suppose there is a path and our body starts to move with initial density u and finally reach to the point with final density b, and when it does so it produces acceleration a and cover the distance yes. We know this formula is very important to us, u plus at. This is the first equation of motion we have proved. Now this formula we already know, v equal to u plus at. So here is v, but we need v square. That means we need the square of this. So that's why what we do is squaring both sides. Squaring both sides. So when it is squaring both sides, it turns into v square equal to this u plus at whole square. So we turn into a square. Or v square equal to, this is in the form of a plus b whole square. So a plus b whole square means formula is a square plus 2ab plus b square. So let's convert into that form. So this is a and this is b. So it begins with a square means u square plus 2ab. 2a means u and b means at plus b square means at is b. So square means whole square. Alright. Now or b square equal to u square. Let's simplify it. So it turns into 2 u a t plus a square t square. Now, if you compare with our equation, so b square we already got, e square also we got. Now from this we want to get 2as. So here we'll apply some trick. So the trick is b square equal to u square plus. Now we want to take 2a common from here. So to take 2 common, both should have 2. Here we have 2, but here we don't have 2. That's why to take the 2 common, you are going to use trick. And the trick is, since we want to take 2 common from here, so 2 must be here. So that's why we'll keep here 2, but we cannot keep 2 without any logic. So to balance it, we keep 1 by 2. So in this way it is balanced. How it is balanced? Because 2 and 2 we can cancel. And cancel means just 1 is left and 1 doesn't change any meaning of this term. So 2 into 1 by 2, and this let's write as usual. So the technique is, why we put 2 here, because we want to take 2 common from here. That's why here must be 2. So that's why I wrote 2, but we cannot keep 2 without any logic. So to balance this 2, we put 1 by 2 as well. So what does it do? It helps to balance, because this 2 and 2 will cancel. So it remains 1, and 1 into a square t square means it will be same. So it won't change any meaning. So that's why we use that trick. Now b square equal to a square, same I am copying, plus now here, see b square equal to a square. Now here is also 2, here is also 2, so we can take 2 common. Now here is also a, here is also a square, so means we can take common a. Here is t square, means we can take 2 also common, but we don't take. So just let's take 2 only common. Now let's write the left one. So left one is 2a we have taken already common, means u and t left. So u t is left. Now plus 2 is already taken as a common, so left is 1 by 2. Now out of a square, a has been already taken as a common, so left is a only, a and t square. So finally b square equal to u square plus 2a. Now see, if you remember, the second equation of motion was ut plus half a t square, means it is yes. So that's why in place of this whole, we can write yes. In this way, we can prove the last equation as well.